Welcome back, students. Today is the session 5 of wave optics and the topic is apparent depth. And in order to save the time, I have already drawn one diagram here in which there is a tank which is filled with water, and there is a coin which is lying at the bottom of this tank, and there is a person who is sighting this coin from the top. Now this is water and this medium is air. Now, because of the refraction of light from this medium water to air, this person who is sighting this coin will find this coin to be raised by a certain height. He will be seeing this coin to be somewhere at this point, which I have denoted by C. Now, the height of this, the depth of this this virtual height, H, is the virtual height of the coin. Virtual height of the coin due to refraction of light. Refraction of light due to the reflection of light when traveling from water to air. That is, this is the virtual height which will be perceived by this person when he is seeing this coin from the top. So this coin, he will be perceiving this coin, and at this point C, and this or you can say that the depth, or you can say the height of this coin will be raised by a certain distance. So instead of seeing this coin at this point O, he will be perceiving this coin at this point C, and this is because of the refraction of light when the light travels from this medium water to air. Now we know that the when the light travels from a denser medium to a this rarer medium, then the refracted light will bend away from the normal. So this refracted light will be bending away from the normal, as I have shown here. Similarly, this here you can see here that this is the light which is getting refracted, and it is bending away from the normal. So this is the angle of refraction, and this is the angle of incidence, that is MBO, or we can also say, and this that is angle M dash BO. This is equal to I, which is the angle of incidence, and this is also equal to angle, that is you can say COB. Similarly, this the angle of here, let us say this is point B, and I'm just taking it as B dash, and this is point A, let us say this is point D, so this is D dash. Now the angle of refraction will be equal to, that will be equal to, this is R, and this will be equal to angle MB B dash, and this is the angle of refraction. So because of the this refraction of light, the coin will be perceived at this height, that is which will be equal to H, and this is also called the apparent depth. The real depth is the depth of the tank, and which will be equal to H in this case. That is, the real depth of the coin is equal to H, and the virtual depth of the coin is equal to small h because of the refraction of light. Now here I have made one diagram here Now this I'm just not, I will be taking two triangles here. You can see this BAC, triangles BAC, and there will be one triangle BAO. So from these two triangles, if I say if AB is equal to, say, x, if this is a AB is equal to x, so I can write that it implies that tan. Now if this angle is R, then this angle will also be equal to R. This angle is already I, that is, I have already mentioned here, that is angle COB, that is angle COB is equal to I, and angle and this angle ACB, this is also equal to angle ACB, that is angle of refraction. Angle of refraction is MBB dash, and this will be equal to, and so this angle ACB will also be equal to R. So tan R will be equal to x upon h, and tan I will be equal to perpendicular upon base. So this will be equal to x upon h. Tan R will be equal to AB upon AC. Now AC here is equal to h, and tan I, this will be equal to AB upon AO. That is, this is basically equal to AB upon AO. So this is equal to x upon h, and this is x upon h means basically it is equal to AB upon AC. AB upon AC. So we have got two equations, that is tan R is equal to AB upon AC, and tan I is equal to x upon h. So from triangles BAC and BAO, if AB is equal to x, then tan R is equal to AB upon AC, which is equal to x upon h, and tan I is equal to AB upon AO, which is equal to x upon capital H. Now if theta is very small, then sin theta is approximately equal to theta, and this is also approximately equal to tan theta. So now you know that the Snell's law. Now as per the Snell's law, sin I upon sin R is equal to n2 upon n1. So this is what we have studied in our previous session. So using this Snell's law, here we can write that sin I upon sin R will be equal to, here I have taken the refractive index of air as mu1, and this is the absolute refractive index, and the refractive index of water is mu2. So in this case, sin I upon sin R can be written as mu1 upon mu2. Okay, so it implies that from this relation we will get mu2 into sin I is equal to mu1 into sin R. Now since if theta is very small, then sin theta is approximately equal to theta, and that can also be taken is approximately equal to tan theta. So what I will be doing is I will be putting the value of this sin I equal to x upon h, because sin theta will be approximately equal to tan theta in case theta is very small. So mu naught into sin I. Now sin I here, since it is approximately equal to tan I, so I will be putting here as x upon h, and mu1 into sin R. Sin R will be equal to x upon h, because sin R will be approximately equal to tan r if theta is very small. So in this case, I will be putting this value as x upon h, small h. So this is the relation which I have got now using the concept of Snell's law and considering that theta is very small. So from this relation we can see this x and x will get cancelled out. So we will be getting as mu2 upon capital H is equal to mu1 upon small h, or it implies that h, that is the apparent depth of this coin, will be equal to can be written as mu1 upon mu2 into h. Now here mu1 is the absolute refractive index of air and mu2 is the absolute refractive index of water, and h is the real depth of this coin, which is equal to, which is basically the depth of this tank. So the apparent height is equal to that, this h is basically the height as perceived by this person who is viewing this coin from this medium, or he is viewing this coin from the top. So this apparent height h is equal to mu1 upon mu2 into h, and this coin will be seen raised by a certain height at this point C. So this is a very important formula, and using this formula we will be solving a number of questions in the forthcoming session. So thank you very much for joining this session, and till then have a nice day. Bye.